Chapter 5 is focusing on discrete probability distributions. In this chapter, it's basically talking about different ways to calculate probabilities depending on different sets of distributions. Section 5.1 is just focused on discrete random variables. Pretty basic introduction to discrete probability. Notice as you go through the sections, try to focus on the properties as well as the formulas used to calculate each of these probability distributions. So with discrete random variables, you can see there on page 263, all the probabilities have to be between 0 and 1, and the sum of the probabilities must equal 1. And they talk there about the concept of random variables and a probability distribution as well. And then on 265, they present us with the formula for expected value for mu. And then a couple pages over, they give us the expected value formula on page 269 for variance and standard deviation. So just be sure you can work through some of those basic problems to calculate expected value with discrete random variables. It shouldn't be too difficult there. Now section 5.2 gets us into binomial distributions. Binomial distributions are essentially probability distributions that only have two outcomes, such as male-female, or if you're flipping a coin, heads or tails. The properties listed there on the bottom of 275. Experiment consists of a fixed number of n trials, identical trials. Each trial is independent of each other. For each trial, there's only two possible outcomes. As we said, for counting purposes, one outcome is a success, the other is always labeled as the failure. Typically, you'll see this as S and F, but textbooks may differ. For every trial, the probability of getting success is called P. The probability of getting a failure then is 1 minus P. Oftentimes that's referred to as Q. The binomial random variable is X. Counts as the number of successes in the n trials. And for the binomial distribution, as long as you do have a binomial distribution, then mu is going to be n times P, the number of identical trials times the probability of getting success. And the variance, sigma squared, is n times P times 1 minus P, or n times P times Q. Those are the properties, and then on 276 they show you the probability for binomial distribution formula, which is pretty basic. The counting rule, nx times P raised to the x times Q raised to the n minus x. You need to be sure and work through some of those binomial problems to make sure you get the hang of them. And these are all different distributions. The calculator also should be very helpful as you go through. There's binomial keys in the 83 or 84 calculators that you can help calculate probabilities. Section 5.3 is the Poisson distribution, another important discrete distribution that you need to be familiar with. On 284, the probabilities there, or the properties of the Poisson, each success must be independent of other successes. The Poisson random variable x counts as the number of successes in given intervals. Mean number of successes in the interval must remain constant, and the mean and the variance both are equal to mu. So mu equals sigma squared equals what we can call alpha, and alpha is the mean number of successes in a given interval. And then the formula for the Poisson is P of x equals E, the natural log E raised to the negative alpha times alpha raised to the x divided by x factorial. E there being 2.718282 or so forth, natural logarithm. Again, be sure you can work through some of these Poisson distributions. They are very intuitive, very important. Also on the calculator, there is a Poisson key for PDFs and CDFs that you can calculate some of these probability distributions. And then the last part of Chapter 5 is the hypogeometric distribution, which also is unique and important in terms of discrete random variables. On 292, The properties, each trial consists of selecting one of the end items of the population, results in either success or failure. Experiment consists of n trials. Total number of possible successes in the entire population is k. Independent trials are dependent. Hypogeometric random variable x counts the number of successes in n trials. Hypogeometric distribution mean is given by mu equals n times k over capital N, and then the variance is given there as well. You can see that long formula with the denominator being capital N squared times n minus 1. The general formula for geometric distribution is given on the top of page 293. Again, I think you should be able to work through the hypogeometric probabilities relatively easily. Now, the discrete probabilities are important, so you can work through those and understand those types of distributions, because in Chapter 6 we get into normal distributions, which is not discrete but continuous, and then we also get into some other continuous distributions as we move forward in the class. Again, when I was taking a math statistics course, much of the course was containing formal proofs of binomial Poisson and hypogeometric distributions. So all of these distributions have in-depth mathematical proofs to show what the distributions look like and how, under certain circumstances, those properties we mentioned, we can get the probability outcomes that we do find. So I hope you're diligent and take time and go through these sections and enjoy Chapter 5. I'll also be posting Chapter 6, which gets us into normal probability distributions, which is incredibly important as we move forward in the chapter in our study of beginning statistics.